Welcome to the landing page for Morph Split. To start a new session, we click the Start New Session button. Next, we'll select the Select Images button to upload our images. I'll navigate to the folder containing the images and select 60 uncropped images so that Morph Split does the cropping for us. Images are being uploaded to a Google Cloud Storage bucket. Once that is done, it will generate a list containing the names of all the images that were uploaded to Google Cloud. Next, we click the Continue button and select the Select Masks button to upload our segmentation mask. I'll navigate to the folder containing the mask and select 60 uncropped mask. The masks are being uploaded to the Google Cloud bucket, and once that is done, it's going to generate the names of all the segmentation masks that were uploaded. Next, I would click the Continue button. Now we could preview the images and their corresponding masks by clicking the slider. So these are the images and masks that were uploaded. Next, we click the Continue button. At this point, we could set the split ratios for the training, validation, and test sets. And once we change one, the others we adjust to ensure that the split ratios sum up to 100%. For our research, we set our training split to 60%. To ensure it doesn't change, we lock the key by the right, and the validation was set to 20%, and the test sets we adjust to 20%. After this, it's time to set the number of images and masks we want to generate for our training set after augmentation. We could set it to 300 images and 300 masks. We'll click Continue. Our data can be split randomly or using stratified splitting. In our case, since the images were going to be used for predicting visual attributes, we need to ensure that all ranges of visual attributes are equally represented across the training, validation, and test sets. To achieve this, we're going to supply a CSV file containing the names of the images, as well as visual attribute parameters for each image, ranging from eccentricity down to uniformity. And for our research, we discovered that the A index, which is a parameter for measuring color, was the underrepresented parameter. So we would use this parameter to conduct stratified splitting of our data across training, validation, and test sets. So to upload the CSV file, we select the Select File button and navigate to the folder containing the CSV file. We'll select the file, and once it's uploaded, it's going to populate the stratified split parameter drop-down list with the names of all the parameters in the CSV file. We'll select the A index, and if we want to see the requirements for preparing the CSV file as well as download a sample CSV file, we can click the information icon. Here we'll see all the requirements as well as the link to download the file. Next, we'll click Continue. Here we could select the random transformations that will be used for image and mask augmentation. In our case, we selected random crop, left to right flip, up to down flip, and random rotate. We didn't alter the brightness, contrast, or saturation of the image, since our model was trained to predict the true color of the food within the image. Morph Split has the capability to augment the validation and test sets. In our research, we discovered that was helpful. It improved the performance of our model because the results from augmenting the validation set were similar to images we captured during the drawing run. So to activate validation and test set augmentation, we activate the slider and click Continue. Here we can crop and resize the images before they are augmented. We'll recall that our original image that was captured is the one on the left, and the one on the right is the image, the cropped version that was fed into the model. To achieve this cropped version, our original image was cropped by 484 pixels from the left to achieve an image of 2000 by 2000 pixels. To get that done, we activate the slider. We set our height offset to 0, our width offset to 484 pixels, our target height to 2000 pixels, and our target width to 2000 pixels. We also discovered that we can maintain the performance of the model even while using a reduced sized image. So for our research, we set our image height to 1024 pixels by 1024 pixels, and we click continue. And this helped us increase our batch size as well as take advantage of GPU size limitations. Next, we'll set the numerical suffix that is used for naming the first image and mask for the training, validation, and test set. We set them to 1. To start augmentation, we click the Augment Data button. Once augmentation is done, it's going to produce an icon to download the augmented data. Once we click that, we're going to see a zip file containing folders for the training, validation, and test sets. It's also going to activate the continue button so that we could preview our augmented image and mask. So we click the download button, and it's going to retrieve a zip file containing our results. We can also view our result by clicking continue. We activate the slider, and we'll be able to preview the training images and their mask. Once we click the validation radio button, we would also see the validation images and mask. So these are the training images and mask. We can view the validation images too, and their mask. So these are the validation results, image and corresponding mask, after augmentation has been applied. And here we're also going to view the test images and their mask. So these are the testing images and their mask. So to end the session, we can click the end session button, or we can also click the reset icon. Here we reset to the original page where we uploaded our data, or we could just also end the session. And once we end the session, it brings us back to our landing page.